What's up, everyone? Welcome to another video. Today, we're going to talk about an industry that, like much of the market, has not done much in recent few months. But this industry is poised for multi years of tailwinds. It's got very high barriers to entry, and the client relations in this industry are very sticky because of high switching costs. This is going to be a fun primer into the precision engineering industry. Welcome to my channel, Inflection Point Research. I'm Karnik. Thank you so much. I really appreciate you checking out our video. And I hope I can provide you something valuable, some insights that you can use in your investment journey. Now, when I say manufacturing in India, what immediately pops into your head? Probably some big smoky steel factories, or maybe an assembly line of Marutis. And you're not wrong, this was the story for a very long time. We sold the world on cheap labor and high volumes. And a lot of our manufacturing was on the lower end of the value addition. It was manufacturing that did not require specialized processes or knowledge. Slowly, a quiet revolution started happening in the background. Our manufacturing started taking off, not only in terms of scale and capacities, but also in terms of the processes. We started innovating. We stopped just bending metal and we started cutting edge engineering and technology based manufacturing. We're moving from cost arbitrage to capability arbitrage. We're moving from manufacturing processes where being off by a couple of millimeters was okay to now in precision engineering where a defect of 1 micron, which is 1/50th the width of a human hair, 0.2%, 0.02% the width of a human hair, that kind of tolerance, that kind of mismatch in expectations can lead to a nuclear reactor shutting down or a plane crashing. This is exactly why this industry is so specialized, why it has high barriers to entry, and why players in this industry need years of audit and permissions before they get approved by their vendors or customers. So this is a traditional in old Indian model where millimeter tolerances were okay, where it was basically we were following a cost plus model, and the outcome was good enough as long as we had to, as long as we were almost there, it was okay. With precision engineering, a micron tolerance can lead to catastrophic consequences. The strategy is IP driven as opposed to a cost arbitrage, and there is room for absolutely no room for error. So now it's not about low cost labor, but it's about making critical components, mission critical components where failure is not an option. Because as we'll discuss in this video, clients for many of these companies are either aerospace companies, nuclear companies, defense companies. And although these parts may constitute 1% of the total cost of the final, in the case of an aeroplane, it might be less than 1% cost of the aeroplane. But despite the 1% cost, if there's even a slight mismatch, it can lead to disaster. So this is basically the litmus test on what defines. A lot of companies call themselves precision engineering companies. But how do you distinguish a commodity manufacturer from a precision engineer? So the first and most important thing is tolerance, because precision engineering is happening in microns, not millimeters, microns. 1 micron, as I repeat, is 1/50th the width of a human hair. So if their measurements are in millimeters and above, it's not precision engineering. Two is the criticality, which I just spoke about. The 1% cost, 100% risk rule. Basically, these parts are like valves, screws, blades. They're a fraction of the bill of an aircraft or of a rocket or of a nuclear reactor. But if they fail, there's catastrophe. And thirdly is the barriers of entry. It takes 4 to 5 years of grueling audits to get approved by OEMs like Boeing and Airbus. So this validation cycle is the primary barrier to this industry. This is basically elaborating that point where the switching costs are just so high that it's not worth changing suppliers to save a few pennies. Once you're approved, usually it leads to recurring orders for many years because certification and audit also takes up to 4 to 5 years. So the key is really getting approvals from marquee OEMs because once that's done, that's more than half the battle. Obviously, like as long as your parts and components are meeting the rigorous standards that are expected. So this is basically the entire value chain of this industry. Let's go from top to bottom. At the bottom of the pyramid, we have companies that provide raw materials. These are like exotic alloys, companies like Midhani, which is a government company. Margins here are the lowest and they hover between 12 and 15%. We'll discuss all these companies in a little more detail. Then next in the pyramid is the precision machining companies. So in this stage is where you basically take the metal and you cut it to perfection using 5-axis CNC machines. Margins in this tier hover between 18 and 22%. And some of the companies here are OBSC Perfection, Azad Engineering, and Miney, which is a subsidiary of Raymond. Then we have the subsystem integrators. These are basically companies that take many of these individual components and integrate it together, assembling a full module. These are companies like Dynamatic Technologies, which makes structures and substructures for Airbus and Boeing. Then you have Data Patterns, which makes electronic warfare systems and radars. And you have Sona BLW. Then on top of the pyramid are basically companies that manufacture machines and jigs. These companies basically design how the factory is run, and they have strong expertise in design and tooling. Margins here cross 25% very frequently. Examples of companies in this tier are Techera Engineering, which it's a very small company, but they make jigs basically for aircraft MRO maintenance, repair, overhaul. Then you have Sansera Engineering, which we discuss in detail further in the video, and KDDL, which we will also discuss in detail later in this video. As you move up in this pyramid, basically your competition reduces and your margins expand. You moving from volume at the bottom of the pyramid towards IP as you go higher in the pyramid. Moving up this value chain requires specialized knowledge and rigorous certification and qualifications, which are directly correlated with higher margins. This is just a further elaboration on what I was just saying. These are the level 4 suppliers, which are basically raw materials. Midhani, Mishra Dhatu Nigam makes super alloys. Then in level 3, you have precision machining. This is basically the engine room. You have companies like Azad Engineering, which make rotating turbine blades. You have OBSC Perfection, which just pivoted from auto to defense and marine parts. Then you have Harsha Engineers, which makes bearing cages. Then in level 2, we have the integrators. These are companies that basically assemble full working modules. This and level 1 have the highest levels of stickiness. Examples are Dynamatic Technologies, which makes aerostructures for Airbus, Data Patterns. And then level 1 is basically Techera, Sansera, KDDL. Yeah. Now let's deep dive into 5 companies that I personally find interesting in this sector. Before we continue, I'm giving a disclaimer that I'm not invested in any of these companies, and neither are any of these companies being given as investment advice. It's purely for informational and educational purposes. Look at these companies as case studies, and if you're interested in investing, please do your own research and due diligence or consult a financial advisor. Right. So the companies we talk about today are Sansera Engineering, MTAR Technologies, KDDL, OBSC Perfection, and Techera Engineering. Each of these companies has a unique story and unique growth triggers. which we'll discuss now. First company we'll talk about today is Sansera Engineering. Basically, Sansera started by making auto components, connecting rods, but they became obsessed with efficiency. They designed and developed their own robotized CNC manufacturing lines. This basically gives them vertical integration and a massive cost and speed advantage. Using their expertise in this, they've basically pivoted because they found an opportunity in aerospace, and they have started winning orders from marquee OEMs like Airbus and Boeing. There's also further optionality as they are targeting the defense and semiconductor industries, which are all three industries, whether it's aerospace, defense, or semiconductor, are poised for growth. And these are one of the good companies from India you can play these sectors through. The next company we'll talk about is MTAR Technologies. If Sansera Engineering was a factory, MTAR is a laboratory. They don't want to make simple screws and components. They want to make 50 different parts which are extremely difficult and complex in making. They specialize in exotic materials like Incocell and nickel. These materials destroy normal cutting tools. Their portfolio of their commendable in their tie-ups, their portfolio includes rocket engines for ISRO, nuclear reactor grids for nuclear power commission, and they make hydrogen fuel cells for this company called Bloom Energy based in America. They make the hot boxes for these fuel cells. So their risk, or also another way of looking at it, is their growth triggers possibly come from their dependence on Bloom Energy. They're very, very heavily dependent on Bloom Energy and the green hydrogen race. It's good in the sense that with ISRO and with nuclear power, they were getting orders which were sporadic and not regular. With Bloom Energy, at least the orders are very frequent and regular, but again, they're very dependent on them and they need to reduce their revenue concentration from this one client. In conclusion, MTAR is a bet on strategic national interests, and it's also a bet on deep science and India's prowess, engineering prowess. The next company to talk about, who I think of as a Trojan horse, is KDDL. So KDDL, if you ask anyone, it's basically a watch retailer. They own the luxury watch brand Ethos, and it's India's largest luxury watch retailer. But hidden inside this company is a subsidiary called Eigen Engineering, EIGEN, Eigen Engineering. So basically, this company applies the watchmaking precision, the Swiss watchmaking precision standards to other industrial parts, from hairsprings to aerospace electrical connectors. They have the heritage and the expertise of basically making very precise metal parts. Recently, they acquired a subsidiary in Switzerland called Estima, and this acquisition basically gives them a direct line into Europe's high-end watch supply chain. So they'll basically be going from making their own watches to making parts for watches for various manufacturers, along with their other engineering business. So if you look at KDDL, it's basically valued like a retail stock, but hidden inside might be highly specialized precision engineering component. Lastly, we'll talk about two companies. These are both very small companies with low liquidity, so be extra careful while studying these companies. The first is OBSC Perfection. They used to make parts for the automotive industry, but they've pivoted towards defense and marine contracts. This reduces the cyclicality of the auto industry and it offers them stickier contracts with better margins. The second company is Techera Engineering. They don't make the parts for precision engineering, but they make the tools that make the parts. They make these jigs which are used by planes when they're being maintained and repaired. So yeah, these were basically the five companies that I wanted to talk about. And basically, what is the investment thesis for the sector? One is the high barriers to entry. Secondly, the industries that they serve. which is very often either the auto, defense, aerospace, semiconductor, medical industries. Most of these industries are poised for many years of growth and have strong tailwinds. Another trigger is the China plus one trigger, as many global OEMs are looking to reduce their dependence on China and looking for manufacturing outside of China. India is the only option with that level of scale and English speaking population, basically English speaking engineering talent to fill this gap. Things you need to watch out for in this industry are one, that it takes time. A lot of these companies take years of qualification before they get approved, and it's very capital intensive in these gestation periods and these trial periods. So financials might be depressed, stock price might be flat or stagnating for a long time before any meaningful inflection. So look out for growth triggers. Metrics to look out for: returns on capital employed, how efficient they are being with their capital, and also the composition of the order book. What percent is coming from defense, what percent is coming from auto. Usually when the defense contribution is more than the auto contribution, this can be a critical shift for these companies. And yeah, with that, we conclude our video into the invisible backbone of India. This has been a video of India climbing up the value chain. These companies are all very unique and have interesting growth triggers. I hope you learned something of value in this video. Please feel free to share your comments, insights. If you have any feedback for me, or if you have any suggestions of a particular sector, industry, or company to cover. Look forward to seeing you again soon. Thanks.